Good. So yesterday we talked about the law of conservation of energy, meaning that energy can't be created or destroyed, and that the total mechanical energy, or the TME, in a system, so this ramp is our system, or the roller coaster is our system, is set. So if you have the total, all it's going to do is fluctuate back and forth between the potential and the kinetic. That's it. Which one did I say I usually like to start with? The potential or the kinetic? Which one is easier to visually see?
The kinetic.
Can you see it moving in here?
No.
On the screen?
No.
No, I can't. I mean, unless maybe like you're like
thought-
bobbleheading around.
Maybe I just wasn't paying attention.
It's easy to flip them. Which one has height in the equation?
Attention.
Potential. Can you visually see heights?
Yes.
Yeah, that is very right there in your face. So there's nothing to really have to kind of visualize. Like it's there. Like I see this height, this height, this height. All right. That's why potential is a nice one to start with. And then once you know the potential, you can kind of work backwards a lot of times and figure out the kinetic. So if I'm looking at this, I have zero kinetic because I'm at the highest potential. I get that. But then down here, I have zero potential because I have all kinetic and I have zero height. Anything times zero is zero, so mass times gravity of 10 times zero makes this potential zero. And so if this is 50, what is gonna be our total mechanical energy? 50, right? 50 plus zero. So if I go back up here, and I want to determine how much potential energy is at the highest point, and I know that it's zero kinetic, how much potential does that leave us? 50, okay? Now, if I am using, I can't remember how this works on, when I click it, can't remember. If I have a total of 50, and I have 25 at this position, how much kinetic does that leave me? 25. Okay, so okay, so I can't remember if I flew in there or if I wrote in there. So this is going to give us our total 50 plus 0 better always equal 50 joules in this problem. Oops, sorry, TME. Better equal 50. This always better equal 50 if I add them up. So 25 plus 25 will give me 50, right? And then my total down here better always give me 50. And that's how we end up being able to figure out this one, well, that one's given, right? So the actual equation is total mechanical energy equals KE plus PE. And so you can either use algebra and solve that, or you can kind of think about it logically. Like this one's probably easy enough. Most of you were kind of doing it mentally. But you don't have to. You can use that equation. Oh, man. Hello? Hi. You're fine. Yep, I can send her. Fine. Kira, Mrs. May needs you for about 10 or 15 minutes. Okay. So, this is a conservation of energy type problem, okay? So we are going to be given some information. So in this situation, we're given the mass and we're given the velocity. And we're gonna have to calculate a bunch of different things at different locations. So it looks kind of like, oh, a lot. It's really not as bad as it seems, all right? Here it has ME, that's our total, okay? This PE obviously is our GPE. So I am going to, I want to go to this one. Alright, so I'm gonna copy over onto the next slide that the mass is 50 and the velocity is 7. Okay, so mass equals 50 kilograms and the velocity is 7 meters per second. Alright, that's our given information. When you're at the very bottom of this ramp, what do you think the height is?
0.
It's gonna be 0. So I'm gonna fill in anything that I know from the get-go. So my height is gonna be 0 meters. Here, it says my height is 1 meter. So I'm gonna kind of put this over here with my other variables. 1 meter. I don't know the height here. All right, what else do we know? If you were at the very, let's see, if you're at the very highest point, what are you gonna have all of? Which type of energy? All right, so what are you gonna have none of? Ooh, that's easy, right? So this is where you have to use kind of that logic part. All right, as I go down here, if I have 0 height, what does that make my potential energy? So there's gonna be things right from the very beginning that you can fill in. That's where I would start, all right? Now, the next thing I'm gonna ask myself, and I'm gonna try to write these, KE equals, I'll put that there. I'll just write it over here. KE equals 1/2 mass times V squared, and GPE is mass times gravity times height. Which equation has mass and velocity in it? Because those are two variables that are given. Which one? Okay, so for stage number 1, I'm going to use this information. All right, so for part number 1, I'm going to use the mass and the velocity because it's the velocity at stage 1. So the mass, though, is going to stay the same because he's the same guy, same skateboard, same everything. So the mass would be a consistent variable, but the velocity is going to change. This is just the velocity at step number 1. So if I take KE equals 1/2 mass times V squared. And again, this is one of the steps that you guys some of you didn't do. And so now it's easier if I just can plug in my variables when I have that equation already written there. So KE equals 1/2 of 50 times my 7 squared. Now I just get to start simplifying, okay? So I can't do anything with KE. Half of 50 is what? 25. And then what is 7 squared? And when you multiply 25 and 49?
1,225.
Thank you. 1,225. That's my kinetic energy. All right, well,
Now you know your TME.
now we know it, because it's 220 or 1225 plus 0. So guess what? We can fill that in at all of them, because for this system, that energy has to stay the same. It is a constant because it's for this system, and that means no energy can be gained, none can be lost. It's just going to transfer back and forth. So it looks like it looks a lot, right? But it's really not too bad. We've already taken care of a lot of it. So I'm going to move on to my next stage or step. And I need PE, I need velocity, I need KE, and I'm given height. Well, I always try to ask myself, for the variables that is given, what equation matches it? So where do you find height? Which one of these equations?
GPE.
GPE. All right. So now I'm going to change my color to blue, just to kind of keep things separated a little bit. So I'm going to go over here and start working at part 2. So my height is 1, right? So I'm going to take my GPE equals mass times gravity times height. Well, we have our mass, right? It's still 50. So I'm going to take 50 times 10 times 1. 500. And that is my GPE. 500, don't forget the J for joules. Now we can figure out kinetic. What's it gonna be?
725.
Because we take our total, I'm trying to do this, we take our total of 1225 equals KE plus 500. So now we are going to do the inverse of adding, which is a subtraction. So if we subtract 500 from both sides, that's how we get our 725 for our KE. Everybody with me? You should be filling these in. You should be doing the steps. One last thing, right? We need the velocity. So what equation do you see velocity in? KE. So I'm going to switch back to red. Okay, so KE equals 1/2 mass times V squared. I'm going to start plugging in. So I know my KE is 725 equals 1/2 of 50 times V squared. This is just like one of the problems you did on that purple paper on Tuesday. So I'm going to simplify as much as I can. So I have 725 equals 1/2 of 50, which is 25, times my V squared. And then this is the step where some of you went wrong. You subtracted 25 from both sides. What should you really do? What's the inverse of multiplication? Good, so I'm going to divide both sides by 25. Gets rid of that, and then what is 725 divided by 25?
29.
What is it?
29.
29? I'm going to scooch over here just because I'm kind of out of room. So when I simplify that, I got 29, and then what I have on my right side is just V squared. Square root it, right? We have to find that square root of both sides. And so what is square root of 29?
5.4.
I like it. Okay, 5.4, and then our units? Very good, meters per second. And I know it's kind of squeezy on there. There's not a lot of, you guys have more room than I do. There's a lot going on, right? But it's just, if you take it step by step, what do I know? What's given? Okay, what equation does that match? Then it's not bad. Okay, so we gotta erase some of this.
This is Duncan.
Yes, sir.
With the top skateboarder, would the PE be 1225?
Sure would. We could have filled that in afterwards, couldn't we? Yep, it definitely will be. So, we know because it's all potential, this is gonna be 1225 for our joules, and that was 0. So, when you add those up, you still get your total, which matches. Okay, so, let's, we have to solve for velocity. Again, which equation has velocity in it? Which one, Deveda? The GPE or the kinetic? Which one has velocity? Yep. Okay, so this is starting number 3. I'm just gonna kind of keep that all set. So, kinetic is 0. If it's got no kinetic, how much velocity can it have?
0.
Oh, sweet! We don't even have to calculate it. Now, could we? Sure. We could put 0 equals 1/2 of 50 times v squared. We could do all the math to get v squared equals 0. Find the square root of 0. You get 0. V is 0. So the math backs it up, but the logic tells us it's 0. Nice. Okay. Another one we didn't really have to do anything for. If you take a second, about half of these are going to be answers like that, where it's just kind of like, oh, okay, like it's already going to be all of it, or it's going to be 0, or, you know, just kind of logically makes sense. So now we're down to one final answer we need. Which equation, Brian, has height in it? Okay, so GPE equals mass times gravity times height. Notice, I am writing this equation every single time. Even though we know it, it makes it easier and less likely that you'll make a mistake if you write it, so then you can just plug things in. So we know that our GPE is 1225. We know that our mass is 50. We know our gravity is 10. And what we're solving for is height. So I need to simplify. I can't do anything with the 1225 just yet. 50 times 10 times h. Now, do I need to subtract 500? What do I need to do? There we go. Divide, because remember, multiplication, the inverse is going to be division. That gets rid of it. And what do we end up with? 2 something? 4 something?
2.45.
Okay. 2.45?
Yep.
Okay, is my height. So let's just round that. We can do 2.5. And then what are the units?
Meters.
Meter.
That was bad.
We're not terrible. We're not terrible at all. So there's a lot going on. But again, about half of it is just like understanding what's going on. Understanding, okay, you have all potential, so you have 0 kinetic. Kinetic is motion. Can't have any velocity if you have 0 motion. Okay? We good? Okay. Let me think. Let me check something real quick. Think about this. Yeah. All right. Let me stop this.